Okay, so dividing rational expressions, it's more or less exactly the same as yesterday when we multiplied rational expressions. We just have to remember our one rule about dividing fractions, which is that we never actually divide fractions. So instead of dividing one fraction by another, we switch it to multiplication, and then we take the reciprocal of our second fraction. So what we're going to do each time is we're going to take this, our second half of our expression, we're just going to flip it over, and that way we can treat it as a multiplication problem instead of division, and then it's just like what we did yesterday. So you're always going to keep your left-hand side the same. Let's need to factor something out, right? We'll factor it as we go. I want to switch division to multiplication, and then I'm going to flip this over. So 1 was the numerator, so I'm going to put on the bottom. I'm going to skip a step. Instead of putting 9 or 9n minus 54, let's just factor that right now. So I know I can take a 9 out from there, and that's going to leave me with n minus 6, right? And so now we're right back to where we were yesterday. Everything is factored as much as we can. So now we just simplify. So since I have an n minus 6 on top and bottom, those cancel out. I'm left with just numbers, so I multiply them together. So 10 times 9 is 90 over 1, or just simply 90. Okay? They're not always going to work out that easily where all the variables go away, but that's the idea, right? So we flip our second fraction, change it to multiplication, factor whatever we can, and then simplify. Okay? All right, so let's try our second example here. So left-hand side, can't do anything with that, so I just bring it down, copy it over, p plus 4 over p minus 7. So you're never gonna, don't ever flip the first fraction, right? You don't have a choice which one you're gonna flip. If you flip the first fraction instead of the second, your answer is gonna be completely upside down, which is wrong. I'm going to make this multiplication. So my p minus 5, that was in the numerator, we put in the denominator. So I'm going to factor p squared minus 3p minus 28. So this would be p minus 7 and p plus 4. Not sure why I'm switching between lowercase and uppercase p, but hopefully you can follow along. Let's see, 7 times 4 is negative 28. Negative 7 plus 4, negative 3, that checks out. Okay. And then I cancel everything I can, which is not too much. I have a p minus 7 and a p minus 7. Remember, these don't cancel out since they're both on top, right? Don't make that mistake. So if I want to rewrite this, I could either put, I mean, we could technically call this p plus 4 times p plus 4. I keep not knowing if I want to make it lowercase or uppercase, over p minus 5 on the bottom. And that's fine. We could also, since it's just p plus 4 twice, so we could say this is p plus 4 squared over p minus 5. Or depending on how it was asking, we could FOIL this out and say this is equal to, so this would be p squared plus 8p plus 16 over p minus 5. So all three of these, oh my goodness, kill me. Click, there it is. So all three of these things are equivalent. So depending on what the answer choices look like, you're going to have to decide which way you're going to have to write your answer. But that's only if and only if we have two factors remaining once we're done canceling everything out. Okay? So math-wise, essentially the same as yesterday. The only thing you need to look out for is remember our rules. I guess I should write this one down. Remember our rules when we did this before, that there was a special factor involving -1. So let's put the rule, like a minus b over b minus a is equal to. -1. So I'll give you a spoiler, that's going to show up at least once on this paper. So you're going to have two factors, right? These will be in parentheses. Right? It'll be the same values, but with opposite signs. And you need to remember these do cancel out, but you have to factor out a -1 first. Okay, so that changes the sign of your whole answer. That's a hint. You don't need it often, but it will show up at least once. All right, good luck.